Hi everybody, Sean here again with another tutorial video. This one's on deflection. So basically over here we've got a cantilever beam and it has a rectangular cross section with a load of P downwards at the free end over here and 2P upwards at the center here. I made Q equal to 2P. Essentially, we have to determine the deflection at the free end of the beam, considering both strain energy due to bending and shear forces. That's part A. And part B is what's the error if we need to neglect the strain energy due to shear force. And then we're supposing the beam length is 7 times the beam depth. Like beam length is denoted by H, depth by beam length by L, and beam depth by H. And the beam has a Young's modulus of E equals 180 gigapascals and shear modulus of G equals 100 gigapascals. Alright, so first things first, we want to draw a shear force diagram. So what that would look like in this case, first of all, there's a force coming down here, and then up to over here, it's like this, and then since this is 2P, this would be like P over here, and this is like P over here, right? Since it goes 2P up and then fixed end over here, so drops back down to 0. So over here, this distance up to the L over 2 point is Z, and this distance up to the next L over 2 points is Z bar. So from A to B, the shear force is equal to P, and the die shear over die P is equal to 1. And next, from B to C, the shear force is equal to P minus Q, and hold on, let's make this look more there better. And the die shear over die P is equal to 1 again. Alright. Now let's continue. For A to B, the moment is equal to PZ. We can get this from from the shear force diagram, and the die M over die P equals Z. Okay. And for B to C, I'm just going to write that one on the next page. M equals P Z bar plus L over 2 minus Q Z bar, and Z or dm over dp or dm over dp equals Z bar plus over L over 2. And so now we have to put this into the general equation of L over, I guess I can give you guys a quick explanation as to why this is. Yeah, the forces, pretty much the shear forces, you look back, it's like a counter of like P, and then yeah, this is the derivative. And for the moment here, like just take P times Z, which is this distance, right? And then for here, it's shear of P minus Q, because Q goes in the opposite direction as P, and dV over dP equals 1. Yeah. Okay, and then for B to C, the moment, you have to take Z bar, so plus L over 2, right? And times it by P pretty much, and subtract it by Q Z bar. And then you just take the moment of that, if that makes sense. Okay. Now moving on to the next part. Yeah. So the general equation is 0 over L over 2, and then alpha shear over GA die shear over die P dz plus 0 to L over 2 M over EI die M over die P times dz plus 0 to L over 2 alpha shear over GA die V over die P dz bar plus 0 to L over 2 M over EI die M over die P dz. And first things first, for alpha equals 1.2 for pretty much any symmetric rectangular section, so then you end up getting this equals 0 to L over 2, and then pretty much once you plug things in, it's like 1.2 P times 1 over GA dz plus 0 to L over 2, and then PZ times Z over EI dz plus 0 to L over 2, 1.2 P minus Q, so times 1 over GA dz plus 0 to L over 2 P times Z plus L over 2 minus Q Z. Yeah, guys, I know it's a little long, but it'll make sense. I'll explain it. Times Z bar plus L over 2 dz, and essentially now we just find the integrals for this, and then yeah, this equation, you could essentially use it to get yourself the deflection. So now you've got 1.2 PZ over GA from 0 to L over 2 plus PZ cubed over 3EI from 0 to L over 2 plus 1.2 PZ bar minus 1.2 QZ bar over GA from 0 to L over 2 plus 1 over EI. So PZ bar cubed over 3 plus PZ bar squared L over 4 plus PLZ bar squared over 4 plus PL squared Z bar over 4 minus QZ bar cubed over 3 minus q z squared L over 4 equals 0 to L over 2. So then when we simplify this out, we get 0.6 PL over GA plus PL cubed over 24 EI plus 0.6 PL over GA plus, no, minus 0.6 Q L over G A plus PL cubed over 24 EI plus PL cubed over 16 EI plus PL cubed over 16 EI again, plus PL cubed over 8 EI minus QL cubed over 24 EI minus QL cubed over 16 EI. Alright. So from this, note that this is where Q equals 2P as we wrote it down in the beginning of the question. So therefore you get a delta P, or a deflection P of PL cubed over 8EI. And the GA terms cancel out. It's just, if you simplify it, this is pretty much what you get. Now on to part B. So first of all, note that area is equal to base times height. Inertia, moment of inertia for like pretty much the shape is equal to like a rectangular beam is, or yeah, the rectangular, it's or a rectangle, like b h cubed over 12, and then e, from this, e b delta p over p equals 12 times 7 cubed over 8 times 1 cubed. Essentially, this part's mostly just some formula manipulation. Yeah, you end up getting something along the lines of this. And then from there, what you need to do next, when you do that, you end up getting 514.5, right? And this is essentially all you do. And then for here, what happens is that this is the same as neglecting strain energy due to shear force as all terms over GA are gone. Yeah. So there you have it, everybody. Thanks for watching another one of my videos. And as always, best of luck and have a wonderful day.